time complexity and space complexity of linear search. Welcome to our linear search complexity training. Understand the concept of linear search. Learn how to calculate time complexity. Learn how to calculate space complexity. Visualize the linear search process. Here are the key aspects of linear search complexity. Definition: linear search sequentially checks each element until the target is found. How to execute: begin at the start of the list and check each item in order. Action: continue until you find the target or reach the end. Time complexity: the time complexity of linear search is O(n), where n is the number of items. How to analyze: count the iterations until the target is found or the list ends. Action: expect an increase in time with larger lists. Space complexity: linear search requires O(1) space, regardless of the list size. How to review: note that no additional space is needed, just variables. Action: utilize minimal memory, even with large datasets. Visualization: visualizing helps clarify how linear search progresses through a list. How to visualize: draw out the process of checking each element. Action: use diagrams to see the search path clearly. Now let's explore some real-world applications of linear search. You're searching for a name in your contacts. How do you find it? Pause and consider. Which name do you search for first? Your action should be: go through each contact until you find the right one. Imagine you're looking for a specific item in a disordered list. What's your approach? Pause and reflect. How do you decide what to check first? If it's missing, continue checking each item until found or ascertained absent. Linear search has O(n) time complexity. Linear search uses O(1) in space complexity. Visualization enhances understanding of the search process. Practice: implementing linear search to enhance your algorithm skills. Thank you for joining our linear search complexity training.